Hello everyone. Today my group Erica, Jared and Wan Yong will present our material selection and sustainability project. My name is Jared. Our chosen product is the archery bow riser, a key component used in Olympic recurve archery. We will briefly explain what the riser does and the key property needed for its material. The riser is the central part of the bow that connects the upper and lower limbs. Modern risers are commonly made from aluminum alloys, carbon fiber, or magnesium alloy. Many Olympic risers are CNC machined from 6061T6 aluminum because it offers good stiffness and machinability. High-end models use graphene or nanocarbon composite for even better performance. Material choice focus on maximizing energy transfer, ensuring consistent shoot behavior, and maintaining structure integrity during thousands of draw release cycle. The riser also need to resist environmental factors as highlighted in no very technical guidelines. The application summary includes align and support limbs, hold side and stabilizer, withstand repeated draw force, reduce vibration, and last ensure consistent energy transfer to the arrow. So now we share about the key properties. First, high stiffness. The riser need stiffness so it does not bend during the shot. A stiff riser ensures that energy from the limbs is transferred precisely into the arrow, improving accuracy and consistency. Novel highlights the stiffness as a critical design requirement. Second, high yield strength and high effective strength. Every time the ball is drawn, the riser experiences mechanical stress. High yield strength prevent permanent deformation, while high effective strength ensure the riser can survive thousands of shooting cycles without cracking. This ensures safety and long-term performance. Third, good vibration damping. When the arrow is released, the riser experiences shock and vibration. Material with good good damping reduce hand shot and provide a smoother shooting feel. Carbon composite riser in particular have excellent damping capabilities, according to UCA 20 and 2025. Fourth, low to medium density. The riser must have a balanced weight, not too heavy and not too light. A typical ideal mass is around 1,300 grams, which provides stability without causing fatigue. Fourth and fifth, high environmental and corrosion resistant. Since the archery is often performed outdoor, the riser must withstand humidity, rain, UV exposure, and temperature change. Hard anodized aluminum and carbon composite are widely used because they offer excellent corrosion and environmental resistance, as reported by Adam Archery. So that's all from me. Now we'll pass to Wan Yong.
Okay, my name is Wanyong. Now I will be presenting the comparison section. In this evolution, there is three materials analyzed, which is a 6061T6 aluminum alloy, AZ31 magnesium alloy, and the Torre T700 carbon fiber reinforced epoxy laminated. This material is analyzed to determine which material is provided the best overall performance for high performance structure application for this boy riser. So when we look at the stiffness, which determine how much the material bend under the load, the aluminum has a modulus about 70 gigapascal, and magnesium is even lower at around 45 gigapascal, making both material is relatively flexible. In contrast, the carbon fiber composite reached approximated 135 gigapascal, almost twice the stiffness of the aluminum, which it will allow to resist the bending more effectively and maintain the better shed stability during the uses. Next is talk about the strength and the fatigue performance. Also show a major difference. The aluminum has yield strength between 240 until 300 megapascal, and magnesium is lower at 140 to 180 megapascal, whereas the carbon fiber inside the composite exhibit extremely high tensile strength around 2550 megapascal. The explosive matrix help to distribute the load across the fiber, slowing down the crack formation and greatly improve the fatigue life, making the composite is ideal for repeated or cycling loading. Next is talk about the vibration damping. The vibration damping is another key factor also. The low damping means a structure will be easily transmit the vibration, noise, and impact. Aluminum has a low intrinsic damping because it has the strong atomic bonds and the alloying element restrict the discoloration movement, which limited the frictions needed to dissipate the vibrational energy. Otherwise, the material is perform a slightly better through a discoloration motion, but the carbon fiber composite provide far superior damping. This is because the explosive matrix is viscoelastic, meaning it absorbs the vibration energy, and friction between the fiber further increase the internal energy dissipation. As a result, the composite deliver the smoother vibration behavior and reduce the short transmission. Is Fourthly, its density also play a major role. The aluminum has a density 2.7 gram per centimeter cube, and magnesium is lighter at 1.78. But the carbon has the carbon fiber limited is the lightest at only 1.55 only. This gives it has a higher stiffness to weight and strength to weight ratio, making it easier to handle while offering a superior structure efficiently. And finally, in terms of corrosion resistance, the aluminum have formed an protective oxide layer, but, but it still can be degraded over the time, especially in the harsh environment. While the magnesium is corrode quickly unless it have a heavily coating. Thirdly, is the carbon fiber or composite also perform extremely well in the corrosion resistance because the explosive matrix is chemically inert and does not react with the moisture or the pollutant in the environment, while the carbon fiber do not oxidize. This allows the material is maintain its strength and appearance even in aggressive environment. So overall, when you considering stiffness, strength, vibration damping, and weight and the corrosion behavior together, the Torre T700 carbon fiber explosive laminated is clearly provided the best combination of properties. For this reason, it is the most suitable and efficient material among the three for high performance engineering application for this boy racer.
My name is Erica, and I'll be presenting for sustainability and social economics and conclusion. Producing virgin carbon fiber is carbon intensive. According to Chen et al., industrial scale production emits around 24.8 kg of CO2 equivalent per kilogram of fiber. When we convert that fiber into a composite like in our riser, the global warming potential can rise about 54 kg CO2 equivalent per kg, as shown by Ramachandran and Ganasagaran. Because our riser is lightweight but long-lived, these upfront emissions are a major part of its environmental footprint. Pre-prep manufacturing generates substantial waste. According to a 2025 review, around 40% of virgin pre-prep material becomes waste during manufacturing. Another economic LCA analysis shows that in some industries, 30 to 50% of carbon fiber reinforced polymer ends up as waste. Parts of this waste can come from trimming of cuts, expired rolls, and unused prep. Carbon fiber epoxy composites are difficult to recycle. However, Torre has developed recycling methods that recover over 95% of the fiber's tensile strength and reduce CO2 emissions by more than half. This allows a circular approach to reduce both environmental impact and future material demand. On the social or economic side, carbon fiber risers are expensive, while largely limits them to performance-focused matches. The global supply chain adds transportation emissions. On the positive side, using a recycling Using and recycling these materials stimulates high-skill jobs and innovation in advanced composites. In conclusion, while Torre T700 risers are high-performing, they have environmental costs in production and generate waste. However, advances in recycling and circular economy strategies offer ways to reduce these impacts. Demonst- to demonstrate that performance and sustainability can be aligned when the full life cycle is considered. This is the list of reference. That's all from us. Thank you.